Hi everybody, Miss Maritello here. In this video I'm going to talk about comparing numbers in scientific notation in standard form. For our first problem, we're looking at a word problem with Sir Paul McCartney and Justin Bieber. So we have Sir Paul McCartney's net worth is about 1.2 times 10 to the ninth dollars. That was according to a website I found on Google. And then we have Justin Bieber's net worth was about $285 million. So we notice right away when we take a look at this that Sir Paul McCartney's number is given in scientific notation, but Justin Bieber's is given in standard form. So there's different ways that you could go about this problem. If you want to pause and try it on your own right now, you can. But otherwise, I'm going to start going through it. I'll show you guys two different methods that we could go through to find who has the larger net worth. So one way that you might choose to go about it is just by figuring out, well, okay, so we see Sir Paul McCartney's numbers in scientific notation, and that's still a little bit new to us. You're still a little bit weird. So maybe you would go and you put that in standard form. If you do, you'll see that because it's 10 to the ninth, and maybe just because of your logic with money, we should know that that's going to be a pretty big number. So when we go through it, 1.2 is our first factor. We're going to move the decimal 9 times to make it be a big number. So then that should give us $1,200,000,000. So then when we compare that then with Justin Bieber's, we can see, okay, Sir Paul McCartney, he's got $1 billion and then 200 million, whereas Justin Bieber just has 285 million. So we definitely should be able to see that Sir Paul McCartney has a lot more money than Justin Bieber. So that's one way that we could go about that problem. Another way that you might consider, though, is instead of maybe putting Sir Paul McCartney's number into standard form, maybe you would try putting Justin Bieber's number in scientific notation. So if you would go about trying to do it that way, you're going to see Justin Bieber, his first factor would have to be 2.85 because we need our first factor. If we're writing a number in scientific notation, the first factor always has to be in between 1 and 10, but less than 10. So we would make it 2.85, and then when I move my decimal point to get to having it in between the 2 and the 8, I should be moving it 8 times. So 1, 2, 3, 4, 5, 6, 7, 8 times. So that would make our number be 2.85 times 10 to the 8th. Again, it's a positive exponent because we know it's a bigger number. But so what you might notice, though, is if you're comparing 2.85 times 10 to the 8th with 1.2 times 10 to the 9th, sometimes people get a little mixed up because they're seeing, wait, well, Justin Bieber, he's got 2.85, so shouldn't he have more money? But we know, though, from the previous that Sir Paul McCartney, he was the one with more money. So hopefully you're realizing that we need to look at the exponent. So because he had 1.2 times 10 to the ninth dollars, we know that then he would have more money than Justin Bieber because his exponent of 9 is bigger than the exponent of 8. So we should hopefully see that when we're comparing these numbers, Justin Bieber really has less money because his exponent's only 8, whereas Sir Paul McCartney's is with a 9. So even if we're doing the problem this way, we should hopefully still be seeing that Sir Paul McCartney would have a higher net worth. And then hopefully you're also realizing that when we compare numbers in scientific notation, you should always be looking at the exponent first. Here's another word problem for us. So it says the distance from LA to New York would be about 2.8 times 10 to the third miles. Then it says the distance from Paris to Beijing is about 5,100 miles. It says which pair of cities are further apart. Show or explain how you know. And I have to say, what was kind of funny when I looked up these distances on the computer, originally when I looked from Paris to Beijing, it was only giving it to me in kilometers, so then I had to look for another website. But if you were to convert this kind of similar to the way we did the last one, if we're looking at Paris, that one, when we convert it, it would be 5.1 times 10 to the third miles. So then this is a little weird then, because in the last problem we talked about how we were going to compare the exponents, but now they're both 3. But hopefully what you might notice is if you were comparing if you were just comparing the exponents, but you notice that they're the same, then that's when you would look at the first factor. So hopefully you're seeing that in the distance from Paris to Beijing, it would be a larger distance, just because then after we see that the first factor is the same, then you can compare the first factors. And you would hopefully know that too, say if you didn't convert Paris, say if you chose to convert the distance with LA to New York, you would see that this would come out to be about 2,800. and about 2,800 miles would be less than about 5,100 miles. But just kind of a note that if you ever do have the same exponent, then you would look at the first factors, but you only do that if you have the same exponent. And one more problem, so this one doesn't have any kind of context, but if you ever were asked to order a couple numbers, I would kind of look at the fact of like, do you have more numbers in scientific notation or do you have more numbers in standard form? So with this example, we have 3 numbers in scientific notation and just 1 in standard form. So my suggestion is to take the number that's in standard form and then convert it to be in scientific notation. So I'm going to take that number, I know 0.005 or 5 thousandths would be 5 times 10 to the negative third. Note we have the negative exponent because we're seeing a small number. I also really like ordering the numbers of A, B, C, and D just because then when I go to rewrite the order, I don't have to rewrite each number each time. I can just write the letter. But again, we're using now like our new knowledge that we know we can compare the exponents. So the smallest exponent that I'm seeing is on the number that goes with C, which was 3 times 10 to the negative fourth, because negative 4 is the smallest exponent, so that must be the smallest number. After negative 4, the smallest exponent would be the negative 3, so that means B would go next, and then A with negative 1, and then D has a positive exponent, so that one definitely should be the biggest, so that would be our last one. Hope this was helpful. Thanks for watching.